Dear students, in this class, we are going to see another scheduling algorithm, which is named as shortest job scheduling. It is also called as second way of arranging incoming process in the system in order to execute. So it is also popularly called as SJF, shortest job first approach. As we see in the last technique, first come, first serve, we can visualize that it is just like a banking transaction where you have a number of customers. Assume these are all the customers are as a process. Each and every process will be selected uh, linearly one after the other to get a service. So here it is clearly mentioned that a process must execute voluntarily till the completion. Once the execution is done, it is going to release the control of the CPU. Once the first process or first customer gets serviced in the bank, so another customer waiting may get the opportunity to get a service in the bank. Similarly, another example you can say for the first come first serve, you have a single printer and many persons are sending a document to print. Here also you can see that a queue will be established. It is called as a linear queue. Each and every document is get printed one after the other. So 1, 2, 3, 4, 5. So here none of the other document is going to print immediately because the technique is first come first serve. With this basic understanding of first come first serve approach, let's see today the shortest job first approach. For example, guys, take the same example. You have multiple process P1, P2, P3, P4, and along with the bus time is given. It is also called as a CPU time: 24 millisecond, 4 millisecond, 6, and 8 millisecond. Arrival time is also mentioned in the table: 0, 1, 2, 3. So, guys, before moving on to this, I'm going to share you another screen so that you will come to know what exactly the meaning of shortest job process scheduling. Okay. So now I'm going to share you another screen. See guys, here you can see that you have a CPU in the operating system. So you have three process P1, P2, P3 associated with a first time 4 millisecond, 8 millisecond, and 2 millisecond. Assume all the process enter into the ready queue. We are in the second technique called a shortest job first. According to this approach, look at all these process. Which process is having shortest bus time to execute or CPU time required to execute? So P1 requires 4 millisecond, P2 requires 8 millisecond, P3 requires only 2 millisecond. According to this SJF technique, so P3, the process P3 will be selected. So guys, this process P3 will be selected by the scheduler. Okay, we have many schedulers, right? So any one of the scheduler is going to select this process and it allow execution by getting the opportunity of CPU. This is exactly what is happening. So P3 is the first process selected for the execution. So how many millisecond required? It required 2 millisecond. After 2 millisecond, this process P3 will be terminated. So again, a controller, it goes to ready queue. Okay, again we have a two process left, P1 and P2. Again we are going to check which process is having a less CPU time associated. Here P1 require 4 millisecond, P2 require 8 millisecond. So what happens here? Definitely here you can see that. So P1, the process P1 will be selected. The first process is this one. The second process is process P1. So it will be selected and it will be go for the execution. So P1 will be in the CPU for the execution. How long? 4 milliseconds. After the 4 millisecond, guys, again process P1 will be terminated. So the last process is left out in the ready queue is P2. Obviously, there is no other process. P1 will be, P2 will be selected. So P2 will be selected by the scheduler and given to the CPU for the execution. So P2. So this is the final process according to the example we taken. So P2 require 8 millisecond. So 8 millisecond it will take and complete the execution. This is the way of process getting selected and executed by the CPU in the approach called as SJF. So shortest job first. So shortest job first algorithm will come into approaches. That is one is called as preemptive. Another one is called as non-preemptive. Now we go back to the previous example what I show, okay, as a non-preemptive. So non-preemptive you already knows, guys. So preemptive in the sense, so a process may be suspended at any point of time, even under execution. But no preemption is nothing but, guys, once you allocate a process to the CPU for the execution, guys, so it will be not suspended until it complete the execution successfully. Once the process get completed execution, automatically it will release the control of the CPU. This is called as non-preemption. So we will go back to our previous example. Let's come back to the example for shortest job first, which is a non-preemptive approach, guys. So as we're aware of, so take the same table. So try to write a Gantt chart, guys. So here what happens, hope you understood this, guys. So this is a Gantt chart I am trying to write now. First, at the time 0 millisecond, any process ready to come? Yes, one process is ready to arrive to the ready queue. So P1 is ready. P1 process will enter into the ready queue. So what you can do is you can give 1 millisecond here, guys, at very first time. After that, so again at the time now, time is 1 millisecond. At this time, check out any other process ready to enter into the ready queue. So P2 is a process at time 1 millisecond ready to enter into the ready queue. So P2 will arrive to the system. Now, so currently already P1 is under execution. P2 is arrived to the system. So allocate 1 more millisecond. So 1 plus 1 will become 2. At the time 2, guys, again one more process is ready. P3 will enter into the system. So at the time 2, P3 is ready to enter into the ready queue, allow it, and again you give 1 more millisecond. So 2 plus 1 will become 3. At the time 3, again process P4 is enter into the queue. Now again you allocate 1 more millisecond. So 3 plus 1 will become 4 milliseconds. Once all the process enter into the ready queue, so you can check out now the shortest job. So which is the shortest process P2? Again, so P2 will continue the execution. So P2 require another 3 milliseconds. So 4 plus 3, 7. So P2 will be executed successfully and terminates. So remaining 3 process, which process is having least CPU time? P3. That will continue the execution. So it require 5 more milliseconds. So it will become 12. So again P3 is going to terminate, means complete the execution. Left out processes P1 and P4. Here again P4 is get the opportunity because it is having less CPU time. It require another 7 milliseconds to complete the execution. So it will become 19. So P4 also terminates after its required time. The last process in the ready queue is P1. So P1 will be allocated the remaining time. So 23 more millisecond is required. So 23 plus 19, 42. So you can verify the last number with the sum of the bus time. So whatever the Gantt chart you written, that will be valid. So remaining thing, once you write the Gantt chart correctly, and after the verification, you go for computing waiting time of each and every process. So there is a standard formula given: turnaround time and waiting time. Waiting time is calculated with the formula starting time of a process minus arrival time, and turnaround time is having again another standard formula that is represented as TAT, waiting time of each process calculated along it will be added with the bus time. So this is how your shortest job execution will happen. So compared to the first come first serve and shortest job first, you can check the average waiting time. So average waiting time of this technique or of this approach, which is very minimum. In the sense, it will give least waiting time of a process to be executed in a ready queue. That's why it is also considered as best approach to schedule a process in process scheduling. So practice with similar examples with different data and a different n number of processes. You may take more than 5 or 6 processes, and you can try with the how to write the Gantt chart and how to calculate waiting time along with the turnover. So see in the next video with a technique called as shortest job first with a preemptive approach. Thank you.